Alright, I'm going to do these videos separately. And the first one I want to do is finding the area between curves. So let's say that I have a curve, two curves. I'm going to call this one y1, so it looks like some sort of function of x, maybe squared, I don't know. So we're just going to call it y1 and understand that it's a function of x. And then I have y2. And I'm just using those really vague things to make it a little simpler. When we want to find the total area through integration, the idea is that we're integrating little increments of area called dA. And basically, depending on your curves, there's going to be two different ways that you're going to do it. For this curve, we might elect to take a little piece like this and call it dA, and we're going to integrate those. Now, when I look at that little piece, to me it looks like a rectangle. And so how am I going to write the area of a rectangle is going to be the height times the width. Now, when I drew it like this, the width, if I look at it, is going to be dx. And then the height is the difference between the two y values, y1 minus y2. Now, and this is what I'm going to want to integrate to find the total area, is the y1 minus y2 times dx. Now, everything has to be in terms of x because we're going to integrate over x because of the dx. That means that we're going to have to write the functions, whatever the function of y1 is, is it x squared or is it x cubed or whatever, and the same thing for y2. So we're going to put in the expressions for y1 and y2, how they depend on x, in order to integrate them. And then we're going to have to figure out, what's the x that we start with and what's the x that we end with. For this one, this would be x1 and this would be x2. In general, how would you find the integration limits? You would be looking for the values for when y1 and y2 intersect or when they're equal to each other. So that's one way that we could be doing the area between the curves. But what if we choose to take a strip that is horizontal? So let's look at that. So what if I have just this curve? Maybe I just call it y equals x, and then this curve, and this is just y equals 3. So for this one, and say we're finding this area, and like I said, here I wanted to look at what if we did a horizontal strip of dA. Now when I look at that, this is dy. So the area is equal to integral of dA. dA is still a rectangle, where it's the height times the width is how I find the area. This time the height is my dy, and my width is going to be, let's call this xr, and then this would be xl. So left and right would be x right minus x left. Now, for this one, when I want to do the integration, and I'm I'm going to be integrating over y because of the dy, so I go from y1 to y2, whatever that would be here. This would be y2, and this would be y1. Again, it would be where the two curves intersect. I have to write this in terms of y. So it's going to depend on what these two relationships are. So, well, for this one, the x right is just going to be x, and the x left is always going to be 0 for this particular one. And we're going to go from y equals 0 to 3. But hopefully that helps you for the area between curves.